We actually looked a lot at product and quotient properties of exponents. It was kind of our main focus. Today we're going to continue looking at those two properties, but we're going to start looking at how they apply to variable bases. So let me explain what I mean by that. Remember that the product property tells us if we're multiplying two powers that have the same base, then we can just add the exponents. And if we're dividing two powers that have the same base, we can just subtract the exponents. So even though we looked at these with specific numbers, like 3 to the 5th times 3 squared at like one base at a time, an important thing to notice is that these properties apply to any real number base. So we can kind of look at, in a more general sense, how do these properties apply and help us simplify expressions. So the first thing we're going to do is look at p cubed times p to the 19th. Remember that we've looked at this something like 5 to the 3rd times 5 to the 19th, and all we did was we took 3 and added it to 19, and that gave us our new exponent. And the same thing applies here, right? I have p multiplied by itself 3 times, and then multiplied by itself 19 more times, and that's a total of 22 times. So we're just applying the same properties to variable bases. So the same property again applies, n to the 6th divided by n to the 3rd. So we have n multiplied by itself 6 times, and we're dividing out 3 of those, which leaves us with a total of n multiplied by itself 3 times. When we get down here, so here I made a quick note. We want to apply exponent rules one base at a time, meaning we're going to look first at the coefficients, the 4 times 3. No exponent rules to worry about there. Then we're going to look at the a's, and then we're going to look at the b's. So the first thing I'm doing is 4 times 3 is 12. Next thing I'm going to do is look at the a's. I have a multiplied by itself 7 times, then 7 more times, and then 3 more times. So that's a total of 17 times, which means we have that coefficient of 12, 4 times 3, times a to the 17th power. And then we're going to look at b, and notice that we have b multiplied by itself once, just b here, and then b squared, so we have a total of 3 times. Number 4, right, this can start getting a little more complex, or at least looking a little more complex, but the same thing applies. We're going to look at the coefficients first, then we're going to look at the a's, then the b's, then the c's. So looking at the coefficients first, I'm just going to simplify or divide 14 by 2. And we can actually just divide that. 14 divided by 2 is 7. Next, I'm going to look at the a's. A to the 5th divided by a to the 4th. So I have a multiplied by itself 5 times, and I'm taking away 4 of those, leaving me with a to the 1st, or just a. Then I'm going to look at the b's. I have b multiplied by itself 8 times, and I'm dividing out 1 of those, leaving me with b to the 7th. And finally, I'm going to look at the c's, but we should notice that c squared divided by c squared just cancels, right? Anything divided by itself is 1, or in other words, it just cancels. So all we're left with, we handled the coefficients, the a's, the b's, and the c's. We're left with 7ab to the 7th. Next examples, we're stepping it up a little bit more still, but we're going to do the same thing. Look at the coefficients first, then we'll look at the w's, then the x's, then the y's. And remember these notes that we've made so far, as well as this one extra note. One thing we're going to do, and this will make a little more sense as we get into 0 and negative exponents later in the week, we're going to leave the variable wherever it has the greater exponent. So if that's in the numerator, we'll keep it there. If it's in the denominator, we'll keep it there. And we're going to subtract out the smaller exponent from there. So let's just kind of start piecing together our new fraction, our simplified fraction. So 9 over 12 is a fraction that we can simplify. Right, 3 goes into both of these, and so dividing 3 out of each spot gives us 3 over 4. We're going to look at the w's, and I'll just make a quick note. Actually, maybe I won't, I'll just mention it. So since the w cubed, the greater exponent is in the denominator compared to this w to the first, I'm going to leave the w down here, and I'm going to apply my exponent rules by taking w multiplied by itself 3 times and dividing out the 1 time from the numerator equals 2. So I want to leave this w where it has the greater exponent in the denominator, w squared. Let's look at x next. So I'm going to leave x in the numerator because I have x to the 100 up here and just x to the 1 on the bottom. For the exponent on x, I'm doing 100, right? X multiplied by itself 100 times, dividing out x multiplied by itself just once and getting 99 times. Then I'm going to look at the y's and see the same thing happen as before, which is that y cubed cancels with y cubed. And so we've handled the coefficients, we simplified the fraction. We've handled the x's, the w's, and the y's, which canceled. We're going to look at one more and kind of handle it the same way. So first I'm going to notice that 4 over 16 is a fraction that I can simplify. So 4 goes into both of these, and dividing that out, we're left with 1 over 4. So since the 1 is being multiplied by a bunch of stuff, I don't really need to write it. I could include a 1 here, but I'm not going to. And we're going to look at, in order, m, n, and k. So first I'll start with m. There's an m squared in the numerator, and nothing else going on anywhere else. So I'm just going to leave that m squared right as it is. We can't apply any exponent rules. Next I'm going to look at the n's. I'm going to notice that n has a greater exponent in the denominator. So I'm going to leave n in the denominator with an exponent of 5 minus 4, which is 1. So I have n to the first in the denominator, or just n. And I also have a k in the denominator that I can't apply exponent rules with because there are not any k's anywhere else. So what I'm left with is 4 over 16 became 1 over 4. The m squared stayed in the numerator. N to the fourth divided by n to the fifth became just an n in the denominator, and k stayed as it was in the denominator. So go ahead and work on today's portion of the weekly assignment, and if you need any help, remember just to reach out to your teacher or come back and look through this video.